Okay, so guys, we're continuing on with the same example we started yesterday about normal distribution. So we were doing some calculations manually, just using the basic distribution from your from the diagram there. We know 34% of the data occurs between the mean and the mean plus one standard deviation. Okay, and so all normally distributed phenomena have those measurements between the mean and the standard deviation. That's how we set up the standard deviation. So today we're doing some of these calculations. It says find P160 less than or equal to X less than 170. Okay, so we should remember in the context of the problem, that's saying what is the probability that the height is between 160, which is like here, and 170, which is like here. Okay, so it's asking us what's the probability of this event occurring between 160 and 170. Now you'll notice that it doesn't correspond with any of the standard deviations on our diagram, which means we can't just look at the diagram and add it up. We need to use technology. So what's the probability of the height being between 160 and 170? Now, I've done this on purpose, okay? In normal distribution, that's what we're talking about at the moment. In normal distribution, there is no significant difference between 100 less than or equal to and less than. All right. The reason being these things occur on a continuum, and so when it says less than 170, it means all the way up to 169.999999999, and you can have an infinite number of nines there, which is pretty much 170. So there's no significant difference when we're talking about normal distribution between less than or equal to and less than. Okay, so how do we do these calculations? There's two procedures. I'm going to teach you the way you're familiar with first, and then I'm going to show you a quicker way. So we pull your calculators out. We'll go into statistics. We'll write the instructions up here. Statistics, distribution, normal, NCD. So statistics, so we go distribution, normal, NCD. All right, make sure your data is variable, as mine is up there. And our lower boundary is the lower end of the area we're interested in this circumstance, 160. Our upper boundary is 170. Our standard deviation is 8, and our mean is 175. So we input all of the information, and then we just press enter. And I've got 0.2355, 0.236. So the probability of a randomly selected student having a height between 160 and 170 centimetres is 0.236. Okay. Part two, what's the probability of the height being less than 180? Okay, so if we think back to our diagram here, so how many people have a height less than 180? Get rid of that line, put that one back in. So 180, that's about here somewhere. And so if we're talking about less than 180, we're talking about all of these events. Every event below 180. Okay? So our lower end then, our lower boundary is minus infinity. It's going to keep going this way forever. And our upper boundary is the 180. So the way we put that in, we press exit. We're going to go to the lower boundary, and you should press, I might just need to make my calculator key a little bit smaller so you can see the exact keys I'm pressing. Calc key small. Okay, we should press minus, and then times 10, or yours might say E plus, and then 99. Okay, so that's minus 10 to the power of 99. All right, and so that's pretty much minus infinity. So we'll put that in. So that's our lower boundary. Our upper boundary is 180. Or I haven't written it up there. Our upper boundary is 180. And so we've got 0.734. The mean and standard deviation remain the same. So here I have minus E99, upwards 180, standard deviation is 8, and the mean is 175. So what we have is the probability of a student having a height less than 180 centimetres is 0.7340, which is 0.734. Okay, any questions at this stage? That's our answer is part A, here's our part 1, here's our answer part 2. Okay, and then part 3 says, what's the probability of it being larger than 185? Okay, what proportion of students are larger than 185? Okay, so the way we would put this in, our lower boundary is with the lower end that I'm talking about. Let's sketch it first because that can help us think of it. Okay, so our lower boundary is 185. So that's 183. So 185 is going to be here, and we're saying larger than 185. So we're talking about this section of it. So what's the lower boundary? 185. And the upper boundary, we're talking about going that way forever. So it's positive infinity, our upper boundary. And so rather than putting minus E99, we're just going to put E99, okay? Times 1099. So let me hop out of there. Our lower boundary, 185. Our upper boundary, times 1099. Okay, mean, standard deviation and the mean remain as they are. And we'll press enter. And so the probability of having a height larger than 185 centimetres is 0.1056. So write 4 figures and then round. All right? Now, when we're solving these problems, right, it's really helpful for you either to put this information down or you can write it down in the way I'm going to show you in a sec. The reason is it shows the examiner what you're putting in your calculator. The second reason is when you finish the test and you're checking over it, you can check to make sure you put the right information in your calculator. So it's better to write it down, although it's not essential for getting full marks for the question. Okay? But I'm really going to strongly encourage you to write it down, and then the same with rounding as well. Okay, let's show you the other procedure that we could use. So if you go to your menu and then to run math, okay, we can do it in here, and it can be a little bit faster if you get good at it. Okay? What we're going to press is option. All right, so it follows these same things, except we're pressing option first. Option, then we press statistics, distribution, normal, NCD. Okay, and it brings up NCD, and the way you put it in, right, the way you put it in your calculator here is you go lower, comma, upper, standard deviation, and the mean. Okay, so let's say we wanted to perform this exact same calculation that we just did. Lower boundary is 185, and then we're looking for the comma. The comma is right below the cos button, because that's where it goes. So we've got 185, comma, E99, comma, standard deviation is 8, mean is 175. Okay, close that bracket there. So we've got all the information there, lower, upper, standard deviation, mean, and we can press enter and we get the same answer, we generate the same answer. Okay? So then, like, how can we use this probability? This is going to be an example of a question that pops up. If they said, let's say there's 200 students, how many are going to be taller than 185 centimetres? Okay? Well, what we have the probability of one student being taller than 185 is 0.106. So if we want to know how many out of 200 are taller than 185, it's just going to be 200 times the probability of that event, 0.106. So it's what, about 21 students. Okay, so we would expect, given 200 students and this distribution, 21 of them to be taller than 185 centimeters. Okay, last one. What is the minimum height someone needs to be classified to be in the tallest 5% of people? So let's consider our distribution here. All right, and they're saying the tallest 5%. So the tallest 5% is going to be like somewhere here, okay, where this area is 0.05. All right, 5% is 0.05. And so we're saying, what is this number K? Okay, what's this number K such that you'll classify it as being in the tallest 5%? All right, so anywhere, either that number or above, you're in the tallest 5% of people. Okay, so what we have is the probability of X being larger than K is 0.05. Right, we want to know what is this height K such that the probability of being in the largest is 5%. What's another way we could think about it? The exact same way you can think about it is the probability of X being less than K. What's the probability of having a height smaller than K? Okay, all probabilities add to 1. If we have 0.05 of being larger than K, then the probability of being less than 1 has to be 0.95. Okay, all those, see how those probabilities add to 1. So then we can perform either of these calculations. Now the way we do that is called, it's a quantile. And so we're in the same thing. We've got statistics, distribution, normal, but then we're going to press inverse normal. Okay, we're going to press inverse normal. So let's go back to the main menu. I'm going to show you where the normal statistics is first, and I'll just make my calcs a bit bigger again. So we go menu, statistics, distribution, normal, inverse normal. So follow me along to there. Okay, so you'll notice we've got a couple of options there. We've got tail, we've got area, standard deviation, and mean. Alright, this is how simple it is for the tail. The question is, which way is the arrow pointing? Is it pointing to the right or the left? Okay, here we have the tail pointing to the right, so we need to make sure it says right. At the moment my tail says left, so I'm going to go down there. You can see there's left, right and central. Central we'll do in year 12, but we deal with left and right now. Right. Okay, area. The area is this number. The probability we're talking about, 5% of the population. That's 0.05. Standard deviation is 8, mean is 175. Let's smack that, execute. 188.158. So I've got here K, 185.15. So we'll just leave it as 185. All right. So what that means, if you're 188 centimeters or taller, you're in the tallest 5%. Okay, based off this distribution. All right, I just made it up. All right. The other way you could calculate this is this same one, isn't it? It's saying what's the height that you need to be taller than 95% of people. Okay. So if you were to calculate this one, all right, we got the tail pointing to the left. The area is 0.95. Standard deviation and mean remain the same. And look, we get the exact same number. Okay? So what that means, if you're 188 centimeters, you're in the tallest 5% of people. And obviously that means you're taller than 95% of people. Okay, so we did two parts there. We did normal distribution calculations, and then we did quantiles. That's enough to answer the questions that are in your notes booklet there. So if you there should be sitting right next to you on the page there. That's what we're going to make our way through. I encourage you to use both procedures. So this one and the NCD, lower, upper, standard deviation mean. Okay, be competent with both. Let's do it.
No, I haven't even answered the first question.
Can we just hit the pause there?